Good morning, good evening, and good afternoon, whichever is currently applicable in your time zone. I am Max, and I will be telling you something about behaviors. Now, behaviors can be quite powerful tools at your disposal and can allow you to create almost semi-autonomous, semi-expanding factions by themselves. While not all the functions necessary for that are available for now, they will be available quite soon, however, with the exception of research. Now, the first things first. A journey of 1,000 miles begins with a simple step. Let us start with a simple task. Let us focus on behaviors and transporting between two storage units, from one side to the other. Now, this is just an example and is not designed to be real-life use, and I will be using debug menu just to skip on clutter, unnecessary junk, and other things that may distract from the topic at hand. So, let us start. There are two ways to set up the transport network, two primary ways, from point to point, and one just using the logistics system. Initially, if the storages or the units between which to transport are within the same power grid, units set to act as logistics support, such as those two scouts, can be ordered to transport units basically by drag and dropping, or by requesting items. In this case, I will request full stack. Many buildings, many structures, components will ask for those transport anyway, mostly because they need it to produce items. For example, if I were to order some fabricator to make metal plates, give me a second, we'll turn off the free construction, metal bars, sorry, it will take the appropriate amount of resources and move it. Now, what we want to do is to be not limited by the power grid range, as it is quite limited. The way that is being shown in the tutorial is to select a unit, right-click on Logistics Network button, choose Transport Route, and then we can select Go To as a source by drag and dropping, and using Store as destination. And it works quite well, especially for workers. There are, however, two problems. First, as you can see, and the biggest problem, is that unit will move the items even if the stack is not full. Let me quickly break the stack and forcefully transport it, and you will see the problem still persists. The bigger problem is that with bigger units, the unit will be moving with more than half cargo anyway. And as you can see, they will grab any resource they can, even if they could have transported more. Now, the first step is to recreate our behavior. Scout, please move away. So let's start by adding a behavior controller. Now, initially it does nothing. Let's take a look at first stop our transport bot, and let us take a look at our worker that stays. It goes to the source, picks things up, and drops it. Then goes to the destination and then drops it. So let's program the behavior. I would recommend you to take a look at all the options as they are provided. We have move commands, component commands, flow commands, there is quite a lot of them. However, you will most likely not use them most of the time. The first things first, if you just take a look at the commands, you will want to move unit, pick up items, move it again, this time to destination, and drop it. The problem is, right now we have no sources and no destinations. So let's go to the top left and choose Add Parameters. We will rename them as Source and Destination. And to move unit, we will simply drag and drop. We basically move the unit to the source, then pick it up, then move, and then drop. And as we can see, we didn't set the item, this source and destination. So let's drag the source parameter and destination parameter. And we can see it works similarly. However, you might have noticed two things. First is that our unit doesn't wait for items if there are none in the source. This is a weakness. So let us fix it first. First, we need to get to where we moved the unit to the target. As we're at the target, we pick up items, and then we have to check if we have any items in the first place. I will add, however, one more trick. Before we fix that element, let us add additional options, and let us add the item to move. If we add this item and select, in this case, metal ore, our unit will move only the item that we were interested in. For example, if you have a bot that is gathering items from all around the map and is dropping it into the single storage block, you can use that filter to limit junk items or things that you don't want to be moved. As you can see, our bot currently completely ignores the turret as it is not listed in our filter and is picking up any metal that we want. Now, the additional bonus to that filter is that we can now go to behavior, stop it, and count how many metal ore pieces we have. So, let's count items we have. We will count the item that we are interested in and drop it. The A will be the amount of items we have. Now, the next step is a math. We need to check how big the A is. Now, if A is equal to 0, as there's nothing, we want it to try to pick it up again. If smaller, should never happen, but just in case, I will link them back to the pickup items. This technically could happen if there is a bug and an overflow for some reason. Almost certainly it will never happen, but just for completion and safety. Now, if there's more than 0 units, so if A value is larger than nothing, so 1, 2, 10, 20, we want it to move to the target and drop off the items. Now, I'm not linking the end here, as by default, whenever there's an end of behavior or node without exit, the behavior will start from start. So let's move it again and see that if there are items here, that is, items of interest, it will now move. Now, the obvious question here is, why did we waste time remaking this behavior if it's doing exactly the same thing that much simpler point-to-point transport? The answer is that we can improve upon this element. First of all, let me start by showing you different order. First, we will compare these numbers, but not on the side of source, but on the side of destination. Let me quickly clean up the connections. So, now, after we move to the target and drop them off, we will count the items here, and if we still have any items, so if there's more than 0 items, let's drop them again. Now, why did I choose that command? Let me show you a problem. This storage block is quite large. It has 24 slots. However, if we were to use smaller block, give me a second, we'll quickly build it. Using the previous behavior, so let me quickly limit it just to that, as we are well aware that our source will have more than 8 elements. After all, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as I want to show the problem anyway. So let's change the destination. Now, you can see that while it does pick up everything that it can, it doesn't wait until there's more space in our storage. This is what we will be fixing first. Adding that loop, as I've shown, will now force our bot to wait until it can actually move some of that items. Let me get our good friend Scout here to make some space. And that's when it will start moving items forwards. Now, we did change the unloading, but we removed the loading. What we can do, however, is instead of using count items, there is a better option. Among all of the options here, we have check brightness, grid efficiency, pick up items, equip components. We can also check the amount of space we have with check space for item. Now, if we have space for our ore, we will simply pick up more. This will force ore to fill it up. We won't be grabbing 1 unit of, for example, blight crystal or blight gas. We will have to wait until we have sufficient amount of material to fill our cargo. Now, once we do have enough cargo, or we can't fit any more, let's move to the output. And we will see now that our good old transport bot is now waiting for resources. Notably, if there's a unfinished stack, as here we can see it's 13 out of 20, it will still wait until it's full. And, as I've said, it will wait until it can unload as well. This way we can save quite a lot of time on moving and energy, on moving our bots there and back half empty. One more thing. As you can see, it's not as fast as moving between two storage places, even if there's enough resource. You might see shortly, let me quickly order a bit faster transport. So first let me turn that one here. Our worker won't have to bother with transport anymore. Too much. I will quickly clean it up. Now, as you can see, once it loads or unloads, it waits a bit. That's when the logic is performed. There are two ways how to improve it. First, you find out interesting behaviors within behavior tasks. What is not written within, for example, pickup items, is that our pickup command will still move to our target first, so we can remove the move unit commands. And, as you can see, it works exactly the same. Well, a bit faster, as it loses one additional command. The second option is to use a global command of flow command of unlock. Usually, when we perform a single command, we take one tick. However, unlock will read as many of those blocks or instructions as possible and perform them if possible. Now, usually, when it comes to pickup items, it doesn't change the performance. Pickup items will still take at least one tick just to pick them up. However, check space item doesn't take a tick anymore. What it does now is pick up items, then immediately check space, and if it's full, it will immediately start the movement. It won't wait additional tick. While in simple behaviors, such as these, the difference isn't that high. In some more complex behavior, this change can be staggeringly important. Now, today I've shown you basically how to move items using behaviors, how to improve behaviors step by step, and some basics of creation and linking of those behaviors. Some of the more complex behaviors can provide you ability to, for example, create and manage entire mining team. However, if I could recommend you one thing is do not try to create highly advanced behaviors from get-go. It is better to create first small steps and then combine them into something bigger. For example, soon, in the next video, I will be showing you how to use move or transport item to destination as a means for construction. We'll be using bot to build a building outside of our grid, which might be a bit more daunting. At the same time, I will show you how close this construction is to exploration supply for example, come here buddy, for example, to supply repair items. However, that will be in the next video. Thank you for your attention and see you next time.